Welcome to Unreal Gems. In this video, we are going to learn how to use Heightmaps to gain some extra detail in our PBR materials. Roll intro. Okay, so next up we have Heightmaps. We mentioned them before when we talked about normal maps. Remember that all of these maps that we are mentioning here are common to both workflows. So let's go ahead and see what the height map is all about. Okay, so what is a height map? It's a grayscale image that we can use to store height data. So what does this mean? It is quite simple. We can, with this and a technique called bump mapping or parallax mapping, we can fake depth. We can fake like the brick popping out of the surface and so on and so forth. We can also, depending on this map, change the actual geometric points. So we can change the geometry depending on this map. We can displace things. So we can interpret it as a height from the floor of a surface. So black will represent the minimum amount of displacement and white the maximum. We can also use HDR textures, so it can also represent units of displacement. So you can actually say that the brick needs to pop out certain amount of units, and you can use that in the shaders to obtain that that change in the geometry of the object. Okay, so first of all we have parallax mapping, which is a technique that displaces the texture coordinates to fake depth. It can sometimes also be called bump mapping or similar things, bump offset in Unreal. So just bear in mind that we have this type of effect with parallax mapping. You can see that as the view angle gets more extreme, it has similar problems to the normal maps because the effect starts fading out and it doesn't look good. So with normal maps, we are able to change the angle of the surface normal, and with height maps and parallax mapping, we are able to provide more depth and create the illusion of depth. Okay, so first things first, we need to again check that our texture is properly sampled and everything is okay. Remember that this is also physical information, so we need to disable sRGB. Once we have this, we can go ahead and import our texture, which is right here in our bump map material. So we are using parallax mapping with the bump offset material node in Unreal Engine. You just need to look for it. It's called bump offset. It's quite simple to use. You can see that since this is a technique that manipulates UV coordinates, it is how it fakes depth. You need to plug the output of the node to the UV input in the texture samplers of the rest of the texture types. So you need to plug it to the base color, metallic, roughness, normal maps, and also ambient occlusion. Okay, so what is the input to the bump offset? Quite simple. You just plug a single channel because it only needs information in a float to the height input in the bump offset node, and then I have created a parameter so that we can modify it in real time to modify the height ratio. The recommended values of this height ratio are between 0.02 and 0.1. So just remember that if you go over these parameters, you are going to see that the effect starts breaking down and you can see all the defects. Okay, so let's go ahead and take a look at if we change these parameters, what happens. So let's go ahead and go to the material instance and let's change here to a plane, and let's go ahead and take a look at the part of the top of the barrel. Let's get close up. You can see that this node has a problem that is called swimming. So when you use the bump offset, since it manipulates the UVs, you can see that sometimes it has small problems because things look like they are moving when they are not. So that's called swimming, and it will be better with the parallax occlusion mapping implementation in Unreal Engine. So let's go ahead and turn it up so you can see how it can break down. You can see that when I turn it up, it deforms depending on how the bump map was created. And you can see that this starts breaking down if we go really high. So just remember that you need to be careful with this and use it carefully. Even going less than 0.02 maybe, but I found that 0.02 here, well, did an okay job. Okay, so once we have this, we can also see it in action in the barrel on our level. Let's go ahead and get a little closer. Let's center ourselves in our barrel, and let's go ahead and apply the material instance from the bump map, the bump offset node. So let's go ahead and look for the material instance. It is right here, and let's go ahead and plug it in. You can clearly see that the geometry looks like it has been modified, but remember, this is only illusion. Nothing is being actually modified, but you can see it looks quite well. Gives the barrel a lot more bumps, and it looks like it has a lot more texture. And you can see that the swimming is not as apparent as in the material instance, so everything is okay and looking good. Since this effect just works with texture coordinates, you don't need to worry a lot about performance because it will be quite cheap to apply. So this is quite easy to use and free in terms of performance. So you can use it at your discretion. Again, just be careful with the extreme angles. Just remember that when we go to extreme angles, the effect loses quite a lot of its quality. Okay, so an improvement for parallax mapping is parallax occlusion mapping. It modifies the algorithm and divides the UV coordinate calculation in different slices, so it improves precision. It also reduces the swimming effect, so it looks way better. And if you combine it with pixel depth offset, so PDO in short, you will be able to also modify the silhouettes of the elements so that they intersect with other objects correctly. So with PDO, you are able to intersect objects properly, keeping their silhouette in the intersection point, while with parallax mapping, you would get a straight line, which didn't look good and was one of its weaknesses. Okay, so to implement parallax occlusion mapping in the Unreal Material Editor, you just need to look for the parallax occlusion mapping node. It's quite simple, and a texture object. We do not use texture samplers for this node, so you just look for texture object also and then switch the texture to whatever you want. Next, we have the height ratio parameter. Remember the strength of the effect, so it is quite simple to use, same as with bump offset. Next, we have the min steps and max steps, which just tell the algorithm how many slices to use for the calculation of the UVs, of the UV variation. Next, we have the Heightmap channel, which just selects a channel from the texture object that has the height information. In this case, I used the red channel, so 1000. I could have used 0100 for blue. You just need to remember a for float constant parameter, and you can choose which channel to use for the height map. Again, we have another parameter which is called plane, so it is the reference plane, so where the base for the UV modification is going to be. So this is quite simple. We will see it later in action. You will see better how it works. Next, we have the outputs. Again, as with bump offset, we have the parallax UVs, which in this case you will plug to every single texture sample UV pin. So remember the base color, the metallic map, roughness map, normal map, and ambient occlusion map. A new thing here is the pixel depth offset, which, remember, will help with intersections, and you just need to connect it to the pixel depth offset pin in the material node. So it is quite simple to use. Again, same with pretty much the same as with bump offset. If we see the material instance, we can modify the height ratio. Remember the strength of the effect. You can see that it breaks down if you choose high parameters, so be careful with this. In my case, I'm going to keep 0.05, which worked quite well. I'm going to leave max and min steps with those values, with the default values, because they work quite well. And remember the reference plane, just take a look. It's just where the plane is located, the origin plane for the effect. So it's quite simple. You can choose whatever you want. I'm gonna leave it at 0.5 because it's quite okay for me. And next, let's see it in action in the level. Okay, so I have my barrel and I'm going to just use the material instance. You can see it switch a little bit. You can see that there is no swimming at all. Even where there is a lot of light, the effect does not break down. And one of the big advantages, remember, is the intersections. So let's go ahead and use the top of the barrel with a plane that I have created to see what I mean by intersections. You can see that here the small bumps and the valleys are intersecting clearly with the plane. This is all thanks to pixel depth offset. So PDO is allowing us to have proper intersections even though we are still not modifying the geometry. So this is quite cool. Again, if I now switch materials and use the old material, the old bump map material, just take a look. The effect is gone. There is just one point at which we see the full plane or not. So you can see it switches at a certain point and that's that. So there are no proper intersections. Okay, so that's pretty much it. Remember, this effect is still quite cheap, but this is a lot more expensive than parallax mapping. Not tons more, but a little more. And just remember to just test in your objective platforms to see if it's performant enough or not. But you can see that the effect is working quite well. Okay, so last up is displacement. Here we use the height map to displace the vertices of a mesh in world space. So this is quite cool because it has proper intersections and you can animate objects using the vertex shader, which is quite cool because it is really cheap. So you can see that you can make objects move, change shape, rotate, and etc. etc. So just bear in mind that this is quite cool and it is quite powerful. So again, here we have the bump map. Remember that this is all fake. The displacement, you can see how it displaces the surface. And again, remember that the intersections were not correct with the bump map. Take a look at the border here. With the displacement, it goes with the surface. So you can see the curves where the surface is displaced. So this is an advantage that we could properly do with PDO, but this is actually modifying the geometry, which looks a lot better. Okay, so back again with our barrel, and we are going to see the material for the world position offset, which is displacement in Unreal Engine. So here we have the material. Again, this is all the same. Texture samplers for base color, metallic roughness, and normal map, and again ambient occlusion. But here the height map, instead of using a node, we are using the vertex normal in world space, which we can read in the material editor, and here we have the direction of the normal of the surface in the pixel that we are shading. And here we can multiply that by our height texture. Again, we can scale it as with the height ratio, and we can displace more or less. By default, I've just kept the displacement present in the height map texture. And with that, we can switch the world position with the world position offset pin in our material node, which is quite simple. As you can see, it is really simple. But here we have a problem. If I now use, for example, an sphere, okay, and I displace it, let me exaggerate the effect. Well, let's do it in the material instance because it will be quite a lot faster. Okay, so let's go ahead and displace here. Now we have no displacement. One is the displacement of the texture. And if I go further, you can see how it starts to break down. But here nothing looks too bad yet. Let's go ahead and use a plane instead of a sphere and you will see what I mean. If I now go to a plane instead of a sphere, just remember that the plane is going to be, let me turn off the displacement and let's take a look at the plane here. Okay, so remember the plane, if I go to wireframe mode, has very little vertices. So just remember that, because now when I displace, take a look at what happens. If I displace it a lot, you can see how things are looking quite bad. Things are not looking like I'm displacing the top of the barrel, of course, but the height map has a lot of more precision here. So why am I not displacing properly the surface of the barrel even though the height map has precision there? Well, because I have no vertices here. I just have a couple of vertices here maybe, and that's a problem because I need to displace vertices. If they don't exist, I cannot displace them. So that's why, for example, if we switch to a sphere, since it has a lot more vertices, we see a different effect and we see more precision where we have more vertices. Take a look at the wireframe render and you can see that I can work with a lot more vertices, so I have a lot more precision. So I'm not only dependent on the height map, but also on the subdivision of my mesh. So this is quite a difficult caveat to understand, but bear that in mind. Now when I go, let me leave this at 1 so that it is not a lot exaggerated. When I go to the barrel and I apply the material, take a look at what happens. Let's go ahead and leave the instance there so we can modify it. Okay, you can see that I am displacing things. I can go ahead and use positive displacement or negative displacement also. You can see that I can contract the mesh, which is quite weird. But you can see that here I have some precision because this is in wireframe, it's quite a lot more detailed, as you can see. But if I go again to the top, you can see how I don't have a lot of precision. It's quite not the best. We used to be able to modify this using tessellation, which would subdivide for us the mesh dynamically if we knew how to do it in the material editor. But right now in Unreal Engine 5, there is no tessellation. So bear in mind that you are tied with world position offset to the original geometry of the mesh. So just be really careful with that, because you are not going to see the results that you want, and that will be the cause of that. Again, if I now use the plane, you're going to see that I have a more or less proper intersection. More or less. You can see that it works okay, but remember that the normal map, which is what brings a lot of the precision, is also not taking into account here. So just remember that. So the intersection will not be as precise as with the pixel depth offset. So just be careful with that, because we also depend, again, for the precision on the vertices. If I don't have enough geometry, if I don't have enough vertices, I'm not going to be able to capture this small detail and these small bumps. So bear that in mind, because it is quite difficult now that we don't have tessellation that would subdivide the mesh for us as we would get closer to camera. So remember that when you are using displacement now. You need to subdivide your meshes a lot if you want it to have a small detail. Okay, so that's it for displacement. This is a little more costly than parallax mapping algorithms, but just remember that you can do a lot more with this. Well, so that has been it for this video. You can see that there are a lot of ways to use height maps to gain extra detail in our PBR materials. As you can see, there is no tessellation, So we need to deal with that and subdivide our meshes more or use other algorithms. But now that you have seen this video, you should be able to deal with that and get the best results. If this video has been useful to you, go ahead, like and subscribe. If you want to learn more about PBR, go ahead and keep on watching this series. We'll see each other in the next videos.